Okay, so we're going to go over these exercises. Among freshmen at a certain university, scores on the math SAT followed the normal curve with an average of mu. This is a typo. Mu equals 550 and a standard deviation of sigma equals 100. Number one, if a student scored 600 on the math SAT, what percentile rank? What was the percentile rank of the student? Okay, so what I'm going to do is I'm going to draw the normal curve. This is not nationally. This is the university or college. And here's 600. And what we're trying to do is we're trying to find the area of the region that lies to the left. And that's what you always do when you're doing percentiles, when you're trying to find the percentile rank. So we're trying to find the area. And we have, I'll just rewrite it over here, this information, the mean and the standard deviation. And my tool is that I'm going to use a TI-83 calculator. Notice if you take 600 and minus 550, you probably do in your head, that's 50. It's half a standard deviation. So it's not that far. It's not even a full standard deviation. It's half a standard deviation. So I can tell you something. Okay, so I'm going to use the TI-83. And I'm going to write second and above variables is distribution. And then I'm going to go to 2, which is normal CDF. And when I get to that point, and you enter that, and then when you get to that point, you write normal CDF, and you put the left endpoint. But there is no left endpoint, so we pick a very small number, or a large negative, I would say. So I put minus. Now, one of the big things that people do wrong here, it's not everybody, every once in a while, I said minus, but what I mean is negative. We use this negative symbol. Okay? So I'm going to put negative. Maybe you can do this. So it's going to be negative. And then I'm going to write second EE 99. And what that's going to do is give the smallest or the largest negative number, the largest negative number I can put in the calculator. That means negative 10 to the 99. So that's negative 1 with 99 zeros. Sometimes I just say, well, why don't I put in, I don't know, I don't feel like doing that. You can put this minus symbol. This is the minus on the calculator, not negative. You can put negative 1, and then I just put a whole bunch of zeros in, like 10 zeros. It seems to be good enough. I mean, especially when the standard deviation is 100. So, okay, could do that. But this is the way I'm supposed to, is put that in there. I mean, when you start going like beyond 3 standard deviations, which if you take 550 and start tracking standard deviations, if you go beyond 3 standard deviations, there's hardly anything there anyway. So if you went 550 subtract 100, 450, 350, 250, say you could, even if you put 100 or if you put 0 there, you're going to get something very close. Maybe the same answer with the decimal approximations. Okay, so this is the right endpoint. Right there is the 600, and then you put in 550 is mu, and then you put in 100 is sigma, and you could use a table, and the thing is we're using calculators. So when I taught this class before, I would just use the table, and I think the table is super fun, but since people have a calculator, anyway, I don't do the table, but you learn more when you use the table. Okay, so putting those numbers in, I'm getting 0.6914 6, and I'm going to round that to 69%, and so I write the 69th percentile. But the thing is, I don't know, I'm always thinking, well, did I get those numbers right? I think it's about right. If you look at it, it's, half a standard deviation. The z-value would be 0.5. I mean, one thing you could do is you actually could go back and look at a table to double check it on the table, let's say. Okay, so then let's look at this one. This is 550, say you have 720 here, and color that in, and we're just going to do the same thing. One thing you can do on your calculator is you can write second entry. So I'm going to have normal, CDF, negative E99, 720, 550, 100. So what's the second entry do? The second entry brings up, okay, first, so where's the second? That's second, and then entry is right above enter. And what it does, if you do that, is it brings up what you had before, the last entry. And if you want 2 entries ago, you do second entry again. And so what you do is you go toggle over and just right on top of what you had before. There's also the delete, and then there's insert. But if you do that, that's going to give us apparently 0.9554. And I'm going to round that off to the 96th percentile. Okay, now what we're doing is we're trying to find the 40th percentile. If you're right there halfway, that's the 50th percentile. So the 40th percentile is this area being 40%. So half the area is halfway is the area of 50%. So we're trying to find this value x. And so this time what we're going to do is we're going to do second distribution, and then we do number 3, which is normal inverse. No, it's almost that. Inverse norm. Okay, so you do inverse norm. You have to press enter. I didn't write that down. And then you put this decimal, well, you have to write the percent as a decimal. So I'm going to put 0.40, you just put 0.4. And then again you put, so this is our percentile, which has to be in, it has to be in the decimal. And then I put the mean and the standard deviation. And that gives 524.66, etc. So somewhere I'm going to write x is approximately 525. So if someone has a score of 525 on the SAT, math SAT, that puts them in the 40th percentile. And you just do the same thing for the 80th percentile. So I'm going to do second entry so I can bring up the exact same thing on my calculator and then just edit the numbers and change the 4 to an 8. So I'll write inverse norm, 0.80, 550, 100. And that gives, I'm going to round, okay, it's about 634.16. That keeps going on forever, so I'll round that off to 634. And then you just do the same things for the 95th percentile, you do second entry. So there's 2 skills we learned here, really. So the first 1 and 2 are very similar, then 3, 4, and 5 are very similar. Okay, so and what are the skills here? Much of it is how to use the TIE calculator, 283. And T84 is really similar. So, but you do have to, convert that to decimals, put 0.95 for 95th percentile. Oh, I guess I'm supposed to draw pictures too. So this is 550, So 80% is over here, so we're trying to find x. And then over here, well, now I'm getting really a little bit I'm sort of drawing it really a little bit too much freehand maybe. But see, what we're trying to do is we're trying to find the x value that corresponds to 0.95. So that's the inverse. Given the percent, can you find x? So you put that in there, and apparently that's 714.485. It goes on. So this is approximately 714. So, you know, the larger the percentile, the greater the score should be, because it means that a score of 714 is a, you know, it's a really good score on the SAT for math. It's more than 95% of the people at this college. Well, a score of 634 that's good. It's greater than 80%. 525, it's only greater than 40% of the people. All right, that's all.